Well, good morning, good afternoon, good evening to everyone, wherever you may be, anywhere across the world. Well, thanks so much for joining us here live today for the one and only Serverless Office Hours, streaming live on Twitch if you're joining us from there, also on Serverless Land, YouTube, and on our LinkedIn channel. My name's Julian Wood. I'm a developer advocate for Serverless at AWS, but I'm ridiculously amazed and so happy to have Alex Brie, who in his part-time is the AWS data hero. And then I was trying to think of how to sort of do a title for Alex. I was just like, DynamoDB expert. I reckon that's going to be the one. How are you, Alex? And welcome to
Doing well. Thanks for having me, Julian. Excited to be here.
No, pleasure. I mean, obviously, you are such a well-regarded person in the world of DynamoDB with so much knowledge to share. So yeah, super happy to be with you. I've been on holiday for a few weeks, so that's called vacation in America land. I live in Europe, so we do have holiday and vacation. So I know that's a bit rude, but so it's nice to be back. Eric's been holding the fort while I've been away. We will be with Alex shortly. I will send his details and links, everything shortly. But just looking back at the past world of AWS over the past few weeks. Last week Eric was with Michael Rainey, and this was Apache Cassandra, serverless Cassandra. So Amazon Keyspaces is a serverless version run, Apache Cassandra running on AWS. So if that piques your interest, head back onto our Serverless Land YouTube channel, and you can hear the recording all about that. Clicking on the wrong bits. And what's new in the world with some sort of new and interesting releases. Obviously, I had to put DynamoDB on the top of the list for today, but there are a new feature that you can it now supports bulk imports from S3 to new tables. Lambda's got an interesting thing. I think one of the best use cases for Lambda is how it connects with Kinesis and DynamoDB, and also MSK and Kafka as these event sources, and Lambda runs the polling infrastructure for you, so you don't have to maintain your own EC2 fleet or containers. And now with MSK and self-managed Kafka, you can support custom consumer group IDs. So that's just going to help scaling things out when that'll be helpful for you. Cognito has now support for AWS WAF, and EventBridge had a big run. We're going to be talking about this in Serverless Office Hours in a couple of weeks' time, hopefully. Receiving events from GitHub, Stripe, and Twilio using webhooks, and there's also Salesforce integration. So of course, lots of stuff always going on with EventBridge. And then a few weeks ago, Lambda did also announce tiered pricing. In terms of some cool blog posts that's coming out, colleague Ben Smith, who's always an expert on step functions, is talking about cost with step functions, and has got some really useful information on how you can use different parts of step functions to scale up and also not be too freaked out about the cost. This you're sort of maybe scratching your eyes and going, what, Kubernetes and Lambda, how on earth in this world of serverless is that all going to connect together? But this is super interesting, and I sort of love this approach that Rajdeep Saha has put together. So the AWS controllers for Kubernetes is a way that you can use this ACK to use Kubernetes to deploy other kind of, I was going to say infrastructure, but I suppose other kind of stuff from AWS. So you can use the ACK, and so you can use kubectl and use some of those Kubernetes command line utilities to actually deploy Lambda functions. So it doesn't mean you need to decide either or between using your Kubernetes APIs and also using your Lambda APIs. Just deploy Lambda from Kubernetes. The world is spinning around, and the Kubernetes people are scratching their heads, and the Lambda service people are scratching their heads. But this is all good when things work better together. AWS SAM Accelerate. So SAM Accelerate is all about improving testing in the cloud. And this now allows you to do it also with nested stacks for CloudFormation. So that's always super good. And then, we're now speaking about consumer group ID support for MSK and self-managed Kafka. Definitely look at Adam Wagner's post for that. Really good details with that. And then when we were talking about EventBridge, I did talk about that Salesforce integration. We're going to be talking about that in a couple of weeks' time, and a blog post all about that. Also, the AWS Service Snippets collection, just some little bits of cool code. I'll show a slide a little bit about that later. But Dave Boyne and my team has put this together on serverlessland.com. You can simply look for the kind of snippets you need, and these can be, not necessarily code snippets, but things like searches that you want to do with Lambda Insights. You can see I'm being on holiday. I'm tripping over my words because I can't remember all the service names. I need to dial into the AWS kind of things. But little snippets of useful things that could be useful to help you build your serverless applications. I think I need to do some more reading. I'm obviously dozing off while on holiday. It is AWS Summit season still in Canberra in Australia. That is in tomorrow. Actually, probably pretty soon if you're in Australia, seeing down under on the other side of the world, and a few more sort of summits coming up. But actually, in London on Thursday, literally probably about 1 or 2 miles in that direction, I'm pointing this way, there's EDA Day, which is put on in with AWS and GoTo and a whole bunch of our cool partners, and that's a code node in London. Some new tickets were released today. I think 40 or 45 additional tickets were released today, so it was previously sold out. There are some new tickets available, so yeah, please come and join us in London, and you can hear all about event-driven architectures. So that's the world of AWS in a serverless in a quick week. But yeah, most importantly, over to Alex de Brie. Misconceptions about DynamoDB. Alex, surely people understand everything there is to know about DynamoDB, or they should, or have I got that wrong?
They should, but unfortunately, I still, on the internet, there's still a few people that are wrong every once in a while. So I was super excited, when you reached out about this one and you said, hey, how about we talk about misconceptions about Dynamo? I was like, oh, that is a great one, because there's a lot of stuff floating around out there. So I think we'll have a good time today, hopefully.
Well, this is also open as well. We've got a whole bunch of people who've already joined us. We've got NoSQL know-how, Kirk internally. Thank you for joining us. Please tell us wherever you are. We'd love to do it. I am seeing some messages about my audio clipping. I promise I will try and see what I can do to sort that out. My mic seems to be blowing the levels. Thanks for the comments. This shows that we are live. So please send us your comments and your questions. Alex knows everything there is to know about DynamoDB, so he would love to answer your questions. It's going to be pretty free-flowing. We're live. Thank you for joining us, and send us your questions. I have just posted Alex's Twitter details. But Alex, should I just share your screen, and how do you want to kick off?
Cool. Yeah, I'll just jump into this, and what I want to talk about today are some misconceptions about Dynamo. I do have a bunch of slides just to help organize the conversation, because otherwise it can get kind of abstract without some examples. But everyone watching, don't feel like you have to listen to me just go straight through this. If you have questions, please just drop them in the comments, and we'll go, because if they're misconceptions, I want to make sure that you're sort of hopefully we're getting on the right page, or you're telling me where I'm wrong here, right? So with that, I tried to think about, what are the common misconceptions I hear about Dynamo, the objections I hear about Dynamo, and these are the 5 I came up with. Some of these are due to an outdated understanding of Dynamo features or missing features, things like that, or how it works. Some of it just relates to hey, how working with a NoSQL data store like DynamoDB works. So these are the 5. The first 2 are going to contain also just a little bit of terminology and facts about how Dynamo works, just to get us all on the same page, introduce an example that way. So first 2, number 1, it's only a key value store. I can't do other, sort of interesting, useful things with it. Number 2, it can't handle unbalanced load. I used to get a lot of people saying, hey, DynamoDB can't handle load, but I think now that we keep seeing the numbers coming out with Amazon.com on Prime Day and Snap using it and all that stuff, people don't get that one anymore, but they say, hey, it can't handle unbalanced load. We'll talk about that one. Third one, this is what I got a lot of feedback from on Twitter. Hey, my data model is going to change. What do I do? I can't use Dynamo for that because I'm a startup or agile, whatever. We'll talk about that. And then a couple feature things. Hey, I need strong consistency. I need ACID transactions, and I'll give you a little bit of background on those. So hopefully we can get through all these. Again, feel free to just drop in questions. And with that, I'm going to go ahead and get started. Again, come at me. Ask questions here. I don't want this to just be a lecture. Anyway, I'm Alex de Brie. Julian mentioned that. Wrote the DynamoDB book, AWS Data Hero. I just love AWS serverless type stuff. If you want the DynamoDB book, go check that out. DynamoDBbook.com. Blah blah. We don't need a pitch. All right, let's go. So first objection or misconception. Hey, DynamoDB is only a key value store, and to do this, I want to start off just giving us a little bit of vocabulary, terminology, just so we know where we're at. Again, I'll introduce one example that I'll use throughout all these different misconceptions to help guide us here. So main vocabulary here is going to be table, item, primary key, and attribute. The example I'll have here is just like a table or a database with users in it. I have users in my application. So if you look at this, I have 4 users. I have myself, and I have a few Amazon folks as well: Jeff Bezos, Jeff Barr, Werner Vogels. If you look at all that data together, that's going to be called a table. So table, similar to a table in a relational database or a collection in MongoDB, it's going to hold all your different records. If you want to look at an individual record, that's going to be called an item. So you can see this individual item, my user record here, that's an item. Similar to a row in a relational database, a document in MongoDB.
Are there any sort of confusing terms when people talk about record, item, or things with DynamoDB that they could be misconstrued, or can those terms be used interchangeably for this little part of it?
I would say for the most part, those are going to work interchangeably. The only thing I'll say, and we'll get into a little bit, is just about, a SQL row is going to be a little more structured, going to have defined columns, things like that. But whereas Dynamo is schema. So I think that's the big difference between us. Yep, a good question. Now, when you create that table, your DynamoDB table, you have to create what's called a primary key on that table. Every item in that table needs to have a primary key and be uniquely identified by that primary key. So here on that far left, we have this primary key. It's the username. That's going to uniquely identify every single user in our table by that username. In addition to that primary key, we'll have attributes, right? First name, last name, email, all these other attributes that you might have on your table, on your records. Similar to columns in a relational database, but as we were just saying, you're not going to define those up front in Dynamo. Outside of the primary key, you don't really define any of your attributes. So DynamoDB is schemaless. You should have a schema, but it'll be in your application. You'll validate it there rather than having the database validate it for you. So that's some basic terminology. Now let's get into that key value part. And the reason people say, hey, Dynamo is a key value store is because it's kind of interesting in how you can query it. I mentioned that primary key, and basically all your data access is going to be based on that primary key. So you can query with your primary key. In this case, by username. It's very easy for me to find a user by username, but you can't query with those other attributes: first name, last name, email, those sort of free-form ones that we haven't defined, in our table and things like that. So this is more restrictive than a relational database in some ways, right? Where a relational database has all that flexibility. So this is an interesting thing people have to learn here. And this leads to that, but hey, it's a key value store objection. And I find when I push on people and I say, hey, what are you worried about when you say it's only a key value store? There's really two different objections that they have here. So the first one is, hey, sometimes I want to read multiple values in a single request. If I'm just doing a key value store, I can only operate on a single item, a single user at a time, but maybe I want to get a batch of related users or something like that. So let's look into that objection. We're going to go back to that primary key concept. So there's this notion of a primary key, but there's actually two types of primary keys. There's what's called a simple primary key, which has one element called a partition key. And there's a second type, which is called a composite primary key. This has two elements, a partition key and a sort key. So going back to that example we already had with our users, that's an example of a simple primary key, right? It just has that partition key element, that username that's uniquely identifying each item. If you're doing a simple primary key table, you are basically in key value mode where you can only work on one item at a time, read or write one item at a time. But if you're using that composite primary key, we can look at this same table. We'll just extend it a bit. And now we have same users in here, but now we've grouped them to where we have a composite primary key. And you can see this partition key is the employer. So we're sort of grouping them together by their employer. Mine's Brie LLC. All these other folks work for Amazon Inc. And we also have that sort key of username that we had before. And it's the combination of those two elements, the partition key and the sort key, that are going to make up that primary key that are going to uniquely identify the user. Now, the interesting thing about this primary key is you can see we have multiple records here that have the same employer that all work for Amazon Inc. And I can actually fetch those together. So I can do what's called a query operation, and I can just specify the partition key, and it's going to return all the employees within that particular employer for me. So I can fetch multiple records in a single request here if I'm using that composite primary key with a query pattern. So that's our first objection. Hey, I want to read multiple values in a single request. You can actually do that with DynamoDB using that composite primary key. That's useful anytime you want to do some kind of grouping, one-to-many, many-to-many relationship. So it could be orders for an e-commerce customer, right? It could be students in a classroom. It could be sensor readings belonging to a particular sensor. You can do that sort of grouping. Just making sure, looking at the questions real quick.
Yeah, well, let me just bring up even the last one. Thanks so much for joining us via Twitch in Urat Gala. How do you categorize DynamoDB as a wide columnar, document store, something else?
Yeah, and you're right. Good question. Good to see you here. I would, it's a wide column one. The downside about wide column, and I even have a little rant about this in a second, is like no one knows what it means. So like key value is a little more approachable. People sort of understand, but I think it's like a misnomer applied to Dynamo. So I'd put a wide column in the same grouping as Cassandra. More in the Cassandra and Dynamo bucket are together, as opposed to Mongo. I'd put more in the document bucket, which has a little more flexibility around how you operate on individual records. Yeah, good question.
Cool, thanks. Yeah, and just Maurice Lacordia, have you seen it? Have you seen it written that DynamoDB can be either a key value store or document store? Do we need to opt into one or the other, or what is meant by this?
Yeah, great question, Maurice. So it's correct. You sort of opt in when you're making that choice of your primary key type. Are you choosing a simple primary key, or are you choosing that composite primary key? I would say if you choose that simple primary key, in some senses, it's more like a key value store, particularly in this sense that we're talking about, where you want to read multiple values in a single request. You can't really do that if you're doing a simple primary key. You can do a scan operation, but that's not going to be super useful in most situations. Whereas if you're using that composite primary key, I wouldn't call it a document store. I'd more say wide column, like Anurag was saying, or like a key value store is somehow how people think it, or key sorted key value, things like that. But you're sort of, when you're choosing your primary key, in some sense, you're opting into which of those two buckets you want to be in.
I mean, part of the implicit question with that, and actually I don't know if my microphone is getting any better. I'm trying to move it around and try to speak a little bit softly, which is completely against my nature, but hopefully I'm not blowing it out anymore. But I suppose implicit in the question is the sort of, what if I've done the wrong thing to start with? I mean, are there any recommendations? Should one always create a primary key and a sort key to start with in case things grow or change? How can one, I suppose, protect against your future design?
Yeah, that's a great question. I would say, so it is going to be a little difficult to change if you decide to change down the line. We're not going to get into single table design a ton, which is like a whole nother can of worms today. But if you're doing single table design, or even a lot of designs, I would generally use a composite primary key, just default into that one, even if you only have simple individual item lookups to start. The only time I wouldn't do that is, hey, if you know that this is just going to be a session store, right, where you're storing sessions for users, there's always only going to be one, you're using it in a very key value way, that's fine. But if you're building if you're planning to do single table-ish design and going to have multiple entities, I'd almost always go with the composite primary key there.
Yeah, I mean, I know there was actually a question about from Zach Jones Noel, a good friend of ours from India. How do you convince folks about single table design to folks with SQL background? And I suppose I was going to add into something like that is, specifically in the world of serverless, we often say, well, use the right database for the job. And also, you could use multiple DynamoDB tables. You don't have to use one. So, how do you speak to people from a SQL background saying, yes, let's use a single table design? Or, are things getting overcomplicated? And, do you just, if your data is never going to be together, do you just have multiple DynamoDB tables? Any thoughts?
Yeah, that's a great question. So it's tricky. I would say, do some research. Like, just modeling with NoSQL is different than with SQL, right? You're going to do a little bit more denormalization probably, and then you might be doing some of the single table design. You absolutely have to go access patterns first in your design. So you need to think about that stuff, and it's a little bit of a mind shift change. So I would say do the work to understand that stuff. In terms of single table versus multi-table, I think there are factors that depend on both. I just wrote a post for the AWS Databases blog that says, like, hey, some things to consider on when you're going to do single table, when you're going to do multi-table. The big thing I like about single table design is it forces you to understand modeling with NoSQL is different, because otherwise people come to Dynamo, it's the first time, they're like, hey, it's table. I know table from a relational database. I'm going to do the exact same thing I've done there. And now they have these like auto incrementing primary keys as their IDs, and trying to force a lot of these patterns onto NoSQL that don't necessarily map to NoSQL. So, I would just say, look at the educational stuff. AWS has a lot of stuff out. I've got a lot of stuff out. Other people there's a really great community around this stuff. Like, just take the time to learn some of the NoSQL modeling principles,
Yeah, and also I think, one of the comments I'll say for single table design, if you're not there yet, it's not as though you're doing it wrong by not doing single table design initially. When you're getting started with this, if you're going to be at huge kind of scale, as with all databases, you're going to have to learn how to use it. So that would be my slight sort of thing. And I'm just posting a link to the single table versus multiple table design in Amazon DynamoDB. So that'll be coming up in the chat, so you don't have to remember it yourself.
For that. Thank you. Cool. So I'm gonna keep on rolling. Great questions so far. So one thing I was gonna say, hey, when people tell me it's only a key value store, they usually have two objections. One is, what if I want to operate on multiple values in a single request? We talked about that one. The second objection is, what if I want to access a single piece of data in multiple different ways, and how do I handle that? And just to remind us, when you're working with DynamoDB, it's very easy to access your data via that primary key, it's not as easy to access it via your attributes. You want to set up your primary key to handle your access patterns. But what if you have multiple access patterns? What if I want to access my users not only by their username, but also by their email address? If I want to look up a user by their email address, so this is the same item I want to access in multiple different ways. Well, this is where we can use something that's called secondary indexes from DynamoDB. And you create a secondary index on your table and basically give it a new primary key. And what Dynamo is going to do is every time an item comes into your table, it's going to replicate it out to that secondary index using that new primary key, allowing you to search records by that. So if I look at this, I'm just going to switch it real quick. This is what my secondary index will look like. This is the exact same data, but now it has that primary key of email, and I can look up users by email. I can use that primary key in a very efficient way rather than having to do a scan and filter through attributes and things like that. So just a quick overview of what secondary indexes are. Hey, again, data from your base, your main table is going to get copied into that secondary index with a new primary key, allow you to use that primary key very efficiently. Now, on that secondary index, you can do read-based operations. You can do query or scan, but you can't write directly to your secondary index. You can only write to your main table, and that's going to get replicated out into these read-only secondary indexes for you. So if we go back to those two objections, right, it's only a key value store. And actually, I want to read multiple values in a single request. Well, there we have a composite primary key. And the query operation, you can fetch related records. You can fetch all the orders for a particular customer. You can fetch all the employee or users in a particular company, things like that. Second objection is, hey, I have a single piece of data. I have a single item that I want to access in multiple different ways. How do I have different primary keys? Well, that's where secondary indexes come in and help you with that. So first objection is it's only a key value store. I think that's not true. And going back to what Anurag came up with, like, where do people get this idea? And it's a tiny nit I have with like the AWS marketing. They have this like purpose-built databases theory, which I think is great to have all these different purpose-built databases. But then they showed Dynamo as a key value store, which I understand like the sort of box that they're in, because wide column isn't sort of a widely known type, and also that's for Amazon key spaces. But I wish there were a better way we could sort of advertise Dynamo there. But anyway,
if you had to name it, what would you put above that?
Man, but you're putting me on the spot here, and that's why I'm really
you don't have to.
Like, I can't do it. Like wide column is just not well enough known, I think, to emphasize what Dynamo is good at. And a lot of people do use Dynamo as like an awesome scalable key value store. So it works in some sense, but I just want people to know it's more than a key value store.
Just
maybe it should say
not boxed in, yeah.
Like more than a
key value plus.
Yeah, there we go. So that's the first one. First misconception. The second one is about DynamoDB cannot handle unbalanced load. I hear this one a lot because there's some old blog posts out there where people sort of get this impression, and I think it's been fixed in the meantime. I also like to show this one just because I think it's going to teach us a little bit about how Dynamo is working under the hood, which is useful to know. So again, let's go back to the table we had. This is the composite primary key, and we talked about how you want to query with that primary key. A lot of people are like, hey, my relational database, I can query by anything. Like, why the heck am I so limited in Dynamo? And for that, I think it's worth understanding how Dynamo is working under the hood, right? So we have this primary key, a partition key of employer, sort key of username. If we look at DynamoDB under the hood, it's not just a single instance that's holding all your data, but behind the scenes, they're splitting up your data into what are called partitions. And these partitions are going to be up to 10 gigabytes in size. So imagine right now I have a 15 to 20 gigabyte database. It's got these two partitions, partition 1, partition 2, each one holding 7, 8, 10 gigs of data. Now, when a new write request comes into Dynamo, that Dynamo front end, this is called the request router. I'm going to do a put request. I'm going to say, hey, I want to insert this new user, Andy Jassy. He works for Amazon Inc. That request router is going to look up my table metadata, figure out what the primary key is, and figure out what that partition key is. It's going to hash that partition key and then figure out which partition it's assigned to. So these partitions are handling discrete segments of your data, right? Non-overlapping segments of your data and handling it that. So this first one, we say, hey, Amazon Inc., that's hosted on partition 1. We're going to go write that item there. And the great thing about this is you can add, as your database grows to 25, 30 gigs, you can add a third partition. You can add 6 more partitions. You could add thousands more partitions. And that first step that's happening is still going to be a very efficient step. So when a write request comes in, if you have a 400 terabyte table or something like that, like Snap does, immediately they're going to be able to narrow it down to a 10 gigabyte chunk, get to that right partition and play around in that. And that's going to be a very efficient operation over time.
Is that just because the hashing function is just such a quick thing to do?
Exactly. Like, yeah, all it's doing is it's hashing, and then it's doing a lookup in a B tree to figure out like who it sort of belongs to. Absolutely. And then go assign it there. So it's just splitting up your data in a very predictable, easy way. And I mentioned like adding more or like if you want to add a partition, but you're not adding partitions, Dynamo's handling all that behind the scenes. You don't even know about these partitions other than that they are there, things like that. So that's what's happening under the scenes with Dynamo. I want to talk a little bit about this unbalanced load misconception here, right? So when you're provisioning throughput for Dynamo, you don't sort of provision servers or anything like that. You just say how many read and write capacity units you want. It basically says how many reads and writes you can do per second. So let's say we provision 300 write capacity units. This says we can do 300 1 kilobyte writes per second across our table. Now, the way it used to work is they would take that provisioned units and split them evenly across our partitions. So if I had 3 partitions, each one of them would get 100 write capacity units. And this works in like the ideal case where, hey, maybe you have mostly balanced load. You know, maybe some partitions are doing a little bit more, some are doing a little less, but it's mostly balanced. It's not super uneven. So, you know, all your consumed throughput is fairly even across these different partitions. I think a lot of people, what they run into is sort of unbalanced load, right? Think if you're like Reddit or Twitter or things like that. Like Barack Obama gets way more Twitter likes and views than I do, right? So he has like a very hot partition, just a lot of followers, things like that. So a lot of writes and reads go into his partitions. You have this unbalanced workload. What you might have then is consumed throughput varies quite differently across these different partitions. And if you look at this partition 1, the consumed throughput is higher than the allocated throughput. So maybe now we're throttling on that particular partition. Even though if you look at the total consumed throughput across our table, I'm not using it all up. So I'm in this bad situation where I've provisioned for this much, I'm using less than that, but I'm still getting throttled on this particular partition because I just have this unbalanced load and it was spread equally. So that's how it used to work in DynamoDB. So it used to be spread evenly across the table. A couple bad things about this, right? It led to unnecessary throttling. It led to situations where you had enough throughput, but it was just allocated to the wrong places. It can also lead to throughput dilution issues where as your sort of storage grew, you might add more partitions, but now each partition gets less throughput than it had before and leads to more unnecessary throttling. They've done a ton of work starting in 2017, 2018, I believe this rolled out with what's called adaptive capacity. So now throughput is allocated where it's needed. So if you have an unbalanced workload, they're going to give more of that capacity to that partition that needs it and less of it from the ones that aren't quite as hot. So it's balancing that for you so you don't have that. And now really the only thing you need to worry about is what is called partition throughput limits. Like one partition has a max throughput it can handle no matter how much sort of table throughput you throw at it. You need to watch out for that. But other than that, you should be good to go in general for that.
Is there anything for adaptive capacity, or that's just the default?
That's just the default. Yeah, and they sort of rolled it out slowly where they're like, hey, at first it's like, hey, we're going to adapt, but it's going to be kind of slow, maybe 15 to 30 minutes to adapt. Now they say it's instant adaptive capacity. So it should shift your traffic around pretty well based on that sort of stuff. Another thing they're doing now that they have this adaptive capacity is they're splitting highly used partitions into smaller ones. So if you have that really hot partition that maybe has a few different items that have uncorrelated access patterns, but they all happen to be hot, you split them up into even smaller partitions where they can each get their own dedicated partition and not be consuming the throughput of others. So they're doing a lot of really good stuff under the hood to help with these unbalanced loads. So the fact that like there's this claim that Dynamo can't handle unbalanced load, and I think that's gone as well.
What work is on your side to make this work behind the scenes? Is it having then an efficient partition key system? Because obviously that's sort of under your control.
Yep, absolutely. The big thing you want to do, just going back a little bit. I mean, you want to do what you can to make sure that your load is more like this than like this, right? Or even a more extreme version of that. So you want to try and use a partition key that's going to align with your query patterns while also being sort of high cardinality, right? So the example being, if you have like a SaaS application that has all these different companies signing up, that company ID might be a good partition key because you have lots of different companies signing up for you. Each have their own users, and now each of them can potentially get their own partition and spread that load across. Whereas, like, if one pattern I see a lot, if you're doing single table design and have multiple different entities in your table, sometimes people put the item type as their partition key, like user, and now all their users are in one partition. Which can work if your load is pretty small and manageable and you're able to handle that. But like at a bigger scale, that's just not going to work because now all your users are going to the same place. It's going to be a really hot partition. So you don't want to do something lower cardinality like that.
Yeah, I was laughing with somebody actually recently who was talking about explaining this sort of concept, and they had this concept of being in Scotland, and they were saying they decided to do an alphabetical sort of kind of thing, and they said, but in Scotland you've got McTavish and you've got McAllister and you've got McDonald's and everything, and there are too many M's, and you weren't spread out across the full alphabet. So I was like, suppose that could apply. That was quite interesting. But yeah, I mean, a question that has come up, similar to this is Saurabh, thanks for joining us via YouTube. My SGR partition key ends up being non-uniform hot, which affects insertions. So yeah, how to handle that apart from coming up from a manual sharding scheme, and is the manual sharding scheme the way to do it? Yeah,
so I mean, if you're running up that limit of actually like your partition throughput limits where you're exceeding that, which is 1,000 writes per second per partition. If you have too many writes that have that same partition key, then you probably do have to look at some sort of manual sharding scheme. A little difficult to get into it here, but there are some things out there as well. If you could buffer your writes in some way, if they're very spiky and maybe it's all right for you to accept them into a queue or some other sort of process where you can get to them eventually and spread that load out a little bit more, maybe you can do something like that. But if that's not going to work for you, then yeah, probably a manual sharding scheme is what you'll have to look for.
Cool. I mean, obviously, this is when you're getting to higher and higher scale. Do you find people maybe over-optimize too early or spend too much time optimizing for databases that aren't going to be doing, 300 write capacity units or something like that? Or should people always plan for scale?
No, I mean, it depends. I think you should absolutely know your stuff. Like, I get a lot of questions like, what if I want to get all the users in my table sorted alphabetically or something like that? Can I put it all into a single fat partition? I'm just saying, hey, just know what that sort of locks you into. You're not going to be able to really scale up to like really huge amounts. But if you don't think, I mean, these partitions can do quite serious amounts, 3,000 reads per second, 1,000 writes per second. Those are, 1 kilobyte or 4 kilobytes and 1 kilobyte respectively. Like, that's a lot of data you're reading and writing to an individual partition. You can really scale that up. So, know what sort of scale you're dealing with. I think if you're an internal Amazon or AWS team, you probably don't want to use any of those fat partitions because anything AWS does is going to hit pretty big scale. But if you're not that, now you can just be a little more flexible on some of those patterns.
Cool. And NoSQL know-how, thanks Coke for jumping in. Another big change last year is partition can do 3,000 reads and 1,000 writes, so no more linear scaling of either or. So yeah, thanks for the additional info.
That's good. That's awesome. Cool. I'll keep on rolling. Good question so far. So I think we're done on the unbalanced load. All right, this is the one that people are most interested in on Twitter. So I wanted to, zoom through the early stuff and make sure we have enough time for this one for sure. So this is probably one of the strongest misconceptions I get. Hey, you can't change your data model in DynamoDB. And again, if we go back to our example before, I mentioned how you have to query with that primary key. And as this sort of primary key is set up, it's very easy for me to say, get this user given this employer and username. I can do that very easily with a get item. Get all the employees for this particular employer. I can do that with a query on that partition key. But I can't say, hey, get everyone named Jeff or get everyone with the last name Brie or different things like that, at least as it's set up this way. So the big thing with Dynamo is you have to think access patterns first. Think about your actual access patterns you're going to use and then design your table for those access patterns as compared to a relational database where you sort of design your table in an abstract way. You normalize it, they sort of match your objects. And then you think, how am I going to query this? How am I going to, set up indexes so those queries are faster? But you think about the access patterns after you've already sort of designed your normalized table generally. So given that, let's talk about, maybe you're a startup, you want to be agile, or for whatever reason, your access patterns are going to change. How do you actually think about this change if I have this sort of table? And the thing I always say is think about what type of change you're talking about, because there are lots of different types of changes, and some are easier than others. And even the hardest one, I think, is generally pretty straightforward and methodical and easy. So I'll talk through each of those. So what type of change do you want? First type of change, what if I'm just adding a new attribute to my items, right? And I'm not going to be accessing my items by this, but I just want to have some sort of new attribute that I didn't have before. This would be like in MySQL, you say alter table, add column, whatever. You give it a default value and things like that. How do I do that in DynamoDB? So in this one, I have these different users and the employers, and maybe I want to give it like this role attribute, right? So some of them are admins, some of them are members or things like that. So maybe I start doing this, I set up admins for everyone, but what about these records that aren't admins, and I have to give it some sort of default role? How do I do that? Well, one thing to remember is like DynamoDB is schemaless. So you don't necessarily have to declare default value in your database code for these existing items. You could handle this in your code, like just in your application layer, and especially like at the data access layer. So if I go into my application and I have this get user function, it passes an employer, passes a username, it goes and retrieves it from Dynamo. I could just in that, data access code, add the default role there. So I look at it and I say, hey, if this user doesn't already have a role, just assign this role to it before I, instantiate this object and send it back to my application to mess with. So I'm just, I'm still having that default value, but now it's defined in my application code rather than at the database layer. And now I don't need to go and rewrite every single item in my table just to add this member role for them. So
in a way, you're doing the sort of schema validation within your code rather than as part of the database design.
Yep, exactly. Now, if some people don't like this, I would say if you do this, make sure it's at the very boundary, right where you're retrieving that item. Make sure you do that so that you don't have everywhere around your code, everyone's got to check for a null role and have the default thing. So make sure you're doing that there. Some people don't like that. I understand. If you don't like that, you can use one of the other patterns we talk about later on. But one thing you can do if you're adding this new attribute is just implement it in code, right? DynamoDB is schemaless. If you have a default value, just put it in your application code. So that's one value. Also, if you're doing single table design and you have the single table, now you're adding a new entity into your table. Like, again, you don't need to change anything about existing entities. You just model out your new entity just like you were starting fresh with a new one, give it its partition key and sort key and start throwing it in your table. So you don't need to change anything there. I'm going to keep rolling. Julian, if you see any good questions, you hit it up because I see them coming in.
Yeah, there's some. Well, let's just jump there. There's been a sort of couple of questions about sort of migrations and this kind of thing in terms of the features. Just look in the chat. Well, I'll just pick up so they're on the video as well. I think this was when you were talking about these sort of access patterns, and there are lack of ready-to-use migration copying features, which is the fear of the changing modules. And then Father Goblin, thanks for joining us as well, says, well, you can also import CSV files from S3 now, so it wasn't just writing to S3. And then Coke jumped in as well. Well, you can import Amazon Iron, DynamoDB, JSON, and CSV formats from S3 as of last week. So great new kind of stuff. So yeah, a lot of flexibility in terms of not being as I suppose frightened when your database design changes, because you can export and import. And then just the last one, because otherwise they're good questions and I'm going to lose my place. Angela, how do you handle most recent N items in a table? Let's say in a blog post. Maybe this is out of order, but
so this is a tricky one, and I would say, are you talking about most recent N items across your entire table? Dynamo doesn't love that question. Hey, give me X across my entire table. It wants you to chunk up your data into partition segments, because usually that's what you have. Usually it's the most recent blog post for this blog, or something like that. But if you're trying to do it across your entire table, that's going to be pretty tricky. I would probably maintain that sort of separately in some sort of way. You could use the fat partition pattern we talked about before, but again, that's going to be like a smaller scale type thing. If you're hitting higher scale, probably don't want to do that sort of pattern. But you could do something like that, or maintain it elsewhere for that sort of thing. If you're talking about most recent N item, most recent N blog post for a blog, that's a very good use case for that composite primary key, where your partition key is that blog name. That sort key is going to be the published date or something like that. It's going to order that for you. You can get the most recent 10 items or however you want to do that super easily.
Cool, thanks. And yeah, just that blog post that Kirk was talking about, the DynamoDB bulk exports, Father Goblin has added it into the chat. So thank you very much.
Thank you, Father Goblin. Yeah, that's a cool feature. Like you can import data into a brand new DynamoDB table. It's also like really cost effective as compared to doing it yourself, which I don't understand some of the magic that's happening there. Basically, they don't even charge you for secondary indexes, which to me would make it seem like they'd have to do all those rights anyway. So I think it's super cool. Check that out. Really going to enable a lot of cool use cases. Cool. So that's the first one. That's the easy one, right? The second one, DynamoDB is all about access patterns. So that's where the migrations get harder. What if I have a new access pattern? And for this new access pattern, it's based on an existing value, right? So we'll go back to the example that we sort of talked about before, right? Where we have this primary key set of employer username, but now we want to read by email address. How do we do that? Well, that one's actually pretty simple. That's that secondary index concept we talked about before. You can add global secondary indexes after your table is created. What Dynamo is going to do is go back and backfill. So it'll read your whole table, scan through it, insert items into that secondary index and make sure that's up to date. And once that's happened, now it's online and you can scan from it. So you're good to go. This is actually a pretty this is the easiest pattern you have. You just add that global secondary index and you can start querying that right away.
I mean, is that an expensive operation in terms of read capacity units or in terms of time? I mean, obviously you're not going to add GSIs, very often, but
Yep.
is that something you should avoid, or
yeah, I mean, like if you have this new access pattern and you're going to do it, it's going to be a one-time cost for you in terms of time and right. But I know like Rick used to talk about customers that would do this once a month for sort of like reporting type purposes. Maybe at the end of the month they needed to record special cases on something. They would spin up their secondary index. It would create that. They'd run a few reports off those things and then just delete the secondary index. So it's not doing all the writes during the month. It's only doing a snapshot at one time. And there you go. So some people do that. But yeah, generally it's a one-time cost and not going to be a lot for you. Cool.
Actually, I will just stick a question in Kando, thanks. But how would you get the total item count across an entire table? DynamoDB streams probably. Because I mean, is that scanning the whole database, or is there some?
Yeah, it depends on like how accurate that count needs to be. So like one thing is that if you do describe table operation, it'll give you a count of how many items are in there. Although that's I believe like up to 6 hours out of date. It's sort of approximate. You don't exactly want that, but if you just want a sense, that can do that for you. If you want an accurate one, and you can deal with a little bit of eventual consistency, I would say probably DynamoDB streams, where you're going to get a batch of records. You'll just figure out how many are in there, then increment a count by the number in that particular batch. You're going to have a little contention on that item, but since it's just an increment, you should be fine. So yeah, you could probably maintain your own count if you want to do something like that using DynamoDB streams. If you wanted like a strongly consistent one, and then you have to do it when you're writing items to the table, now you have a ton of contention on that item. I'd be nervous about that one. Yeah. So yeah, those would be the options.
And then I suppose also, Kartik, thanks, how to delete multiple records in one go in DynamoDB other than the batch write way?
The batch write way. The batch write way, or there is a transaction API, which we'll talk about later. It depends, like, do you want to do it, either it all succeeds together, all fails together, or can you have sort of independent success and failure? Batch write, is going to be sort of the highest throughput and cheapest one, but you can deal with failures, and you'll just have to deal with those sort of with retries and things like that. Cool. All right, I'll keep rolling here. Next one. This is the harder one. This is the one people actually worry about. Again, Dynamo is about access patterns. So how do I enable new access patterns, but it's on like a non-existing value? And this is, because if it's on an existing value, as we saw, you can just index that value and you're good to go. So this one's a little trickier to understand. I'm going to extend our example a little bit. One thing I'm going to do with our users is I'm just going to add this date created date. It's going to help me with my example here. So we have first name, last name, email, date created, and the role. Now let's say someone comes to me with a new access pattern. I want to be able to filter by employer and role, and I want it ordered by date created. That's the access pattern I have. So I want to say, give me all the users that work for Amazon that are admins, and then order them by the date that they were created. In order to do that, you'd probably want a table or a secondary index that's set up like this, where the primary key is a partition key of employer, and the sort key is this combination value, where it includes both the role and then the date created. And just the way that DynamoDB, that sort key is going to work, it allows you to handle that sort of filtering plus sorting mechanism that we talked about. So then you could say, you could do a query with that partition key as employer, and then you could say, hey, everyone that's an admin and order by date created. This would do this for you. And if you look at this attribute, role date created, it's basically concatenating two other values. So I have two other columns, the role column and the date created column. You have to concatenate them into two values. So now I have this new access pattern based on this attribute, role date created, that doesn't already exist. So I can't just set up a new global secondary index. So that's where I need some sort of change. This is the migration most people are worried about when this happens. Let's walk through how it actually happens. This right here, this is a script you need. It's a 3-step script. It's small, so I'm gonna enlargeify it for you. So let's look at this first part right here. Basically, within this while loop, so I'm just running this in a loop. The first thing I'm going to do is scan to identify our items. So I'm going to run a scan over I'm basically doing an in-place ETL process here. I'm going to scan across my table, which is just going to give me all the items in my table. It's going to do it in 1 megabyte chunks, so it's going to paginate over that. So I'll scan across my table. When I get a batch of records, let's say I get 100 records back. Then I'm going to move on to step 2. So for each item we find, we're going to update this item with our new attributes, right? So we have this new attribute called role created at that we want to assign here. So for each item in our results, we're just going to do an update item. We're adding this new attribute based on existing attributes. Once that's done, now we need to paginate, right? We've gotten through our first batch of records. If there's the last evaluated key in our scan results, that means, hey, there's still more records to do. You need to go paginate through that. And it's going to just run in a loop until that's done. But basically what you're doing, you're just scanning through your items, adding this new attribute and continuing on there, right? So now I have this role date created value added to each one of my items in place, right? Another thing while we're doing this, if you have some like default values that are, corrupt, like we were talking about the default role value in the past, you might as well just update your items to include this member value. And also, if you didn't like that first pattern I was talking about, where it's like, hey, you implement it in your application code, I actually want to have that on my actual items. Maybe that helps for BI reasons or just sanity reasons, whatever. You can add this role value there as well and just sort of fill in that value. So this same process works for both of those.
So in a way, you're saying that take the one-time hit of rewriting stuff to your database to update your database for the efficiency of reading it later on.
For that member one.
Yeah.
Yep, exactly. And some people like that just because it can be conceptually difficult to be like, okay, what values are definitely going to be there or what could be null or things like that. Where, if you actually do that, you can do that. Or you can just wait until you have a time where you actually, if you're adding this role date created, maybe you say, hey, what null values do we have in our application code? Let's move that to our database code now by batching both of these writes together in a single update request. So again, how this works. You're doing an in-place ETL. You're saying, I have all this existing data in my table. I just need to do an ETL, extract, transform, and load, right? I'm doing an in-place update of that where I scan my whole table, I update the items that I need to update, and then I paginate over it until I'm done. Now, you might say, hey, I have a 400 terabyte table. It's going to take forever. Well, you can do parallel scans. This is really cool with Dynamo. When you're doing scans, as one of the two of the parameters you pass in, you can say, hey, I'm actually doing scans with 500,000 workers. And this is worker number 3,721 or whatever like that. Give me just that chunk of workers. So now you can parallelize that out without you having to maintain the state of which workers have seen what. You just say, I am worker number N out of M workers, and it's going to process that for you. And you can do that up to 1 million workers, which is really good. It can do it really quickly. And then, you can run this on whatever you want. If you're Lambda people, you can do it Lambda. If you like step functions, that's a great way to handle it. Fargate, EC2, if you want to save on compute, maybe because it's a quick steady process, like do that. This will all work. I honestly, like, one of my AWS wishlist things is that they would enable this on your table. I do something called table functions, where I could just say, here's a function, run it over all the rows on my table. Just feed my rows into that and let me do something on it and just do this a managed process. If they don't do that as like an actual service, I think there's an open source solution that could be done here. Rafal Walensky was working on something like this. I think this is just like a simple enough thing, scan, update, paginate through that like this should be super easy for us to do. And once you do it one time internally, like you're going to have the framework to do this and do it yourself.
Yeah, and I'll definitely say, not that I've done it myself, but I mean, certainly, I think Lambda, Fargate, and EC2 may be obvious because they're compute services, but step functions with their SDK integrations, you've got, map state with massive parallelization built into step functions. Consider that. That's, then there's no actual, very little code you need to run and manage.
Yeah, super cool stuff. So that's the scary migration for most people. Hey, how do I sort of go back and do that ETL again? Do that in-place ETL process. It's not that bad. Once you've done one, every single one feels fairly easy. You got to make sure you add a new GSI as part of that and update your application code. So items going forward, we'll be doing that as well. But that's the big part there. Last thing I want to say, because I don't want to evade. Listen, there are some harder cases. Those are. I'd say the three above cover like most of the cases you're going to have, but there are some harder ones. If you need to actually change the main primary key on your base table, that's a difficult one because you can't update an item to change its primary key. You're probably going to have to either go to a new table or just do some sort of like insert and delete type operation on your existing table. So that's a tough one. Also, if you're doing like a new aggregation, so if you're trying to like aggregate some items and then store it onto a parent record, that can be tough to do in place just because if new data is coming into, are you getting an accurate look at that? That's very situation dependent. And I would say make sure you understand your needs, how accurate, inaccurate they have to be, different things like that. So it's doable, but I can't really offer broad advice there. But I think that's a lot more rare than the other ones there.
Are you a fan of just calling the partition key PK and the sort key SK to keep that generic so you don't have, I know you're not necessarily changing the access pattern, but your previous example where it was by username and then you also want to use the partition key for something else?
Yeah, I generally do. Again, that goes back to that single table versus multi-table thing and a little bit on your team, figure out, are you in a situation where you almost definitely should use single table, then do it. If you're in a situation where hey, you could go single table or multi-table, if you want to go multi-table and have more specific primary key names, username, email, rather than PKSK, that's fine with me. I like PKSK, again, just because it forces you to think access patterns first a little bit is the big thing for me anymore.
Cool. Can we just jump in with one question? I know we've got more stuff to do, but yeah, it's all coming in. I love the questions. That's great. How do you handle single for items with various attributes? E-commerce product data where a compute item has various kind of things. Is there a method to handle dynamic access patterns? Or is this the tipping point where one should hand these requests over to a search service? That was what piqued my interest in this question is, where does one move away from to a dedicated search service rather than expecting your database to do it all?
This is honestly one of the tougher problems or tougher things to handle with Dynamo. If you have multiple optional attributes that you can filter on, right? And even thinking about apparel, you said color, size, fabric, maybe brand, a few more. And some people could filter on some of them, but not all of them. So how do you handle all that stuff? Dynamo primary keys and secondary indexes aren't great at sort of optional values generally. So I think one pattern you can do is hey, can I reduce the search space down enough? Maybe I have 150 apparel items, and maybe it's okay for me to hit all of them and then do the filtering after the fact on the attributes where I'd say, hey, maybe I'm overreading a little bit, but it's still a small enough search space that it's easier to do it that way than to send it off to another service and deal with something like that. So if you can reduce your search space, that's a good thing. But if you really do have a really big search space, then it gets into some trickier things. It might be easier for you to move off to something else. I know Rick was saying that a lot of Amazon uses Dynamo for the filtering type stuff, and they'll just they'll overread and do some of that filtering. They'll cache a lot of that stuff too. So it's definitely doable. It just depends a little bit on some of your specifics. Cool. Also, a couple things I want to call out just on migrations to finish that. I was talking about migrations last week. I got some good tweets. So Barney, one thing he pointed out, it feels hard because you have to do this migration with Dynamo if you're doing that in-place ETL. But one thing Barney's pointing out is hey, SQL migrations, they're going to get more and more painful as your data grows until they're essentially impossible, right? There's GitHub has their Ghost framework, and I know relational databases are getting a little better at online migrations and stuff, but it's still a scary operation, especially once your data gets big. So it's not an easy path there. The nice thing about Dynamo is they're not going to get more painful, right? The process. It's this 3-step process. You run it in the background. Once it's done, you're good to go. Same thing from Tobias here, my fellow Nebraskan, like saying, hey, having done both MySQL and Dynamo migrations, like he'd way rather do Dynamo ones. So it feels different. It's different than doing just like alter table, add column, or add index, or whatever you want to do than a relational one. But again, remember, that's hiding work under the scenes that at a certain scale is going to be difficult for you. So, all right. So you can't change your data model. Are we time limited here? Because I can do the 2 more, or I can.
No, let's go for it. I will check whether there's something coming up after Twitch afterwards. But yeah, I think we're actually not today, amazingly. Okay. So we can go a bit longer if you can.
Because I can do whatever. You guys let me know. If you start getting off the stream, that's all right. Julie and I will just talk between ourselves about these things. So, but okay, the next one I get, these are kind of interesting, is, hey, you can't use Dynamo if you need strong consistency, right? Because a lot of people have heard about how Dynamo has eventual consistency. That seems scary to them. What if I sort of deduct a bank balance that doesn't have any money in it or something like that? Now I'm out that money. So let's think about what's going on here. And when we're talking about consistency in a database in terms of eventual versus strong consistency, what we're talking about is replication. You might have data in multiple different places, and one of them has an outdated version of that data, right? So let's go back. We talked about how Dynamo is partitioning our data across multiple different partitions. I want to go a little deeper there. And each of these partitions I'm showing is actually the primary, right? So there's a primary for each of those. But then that partition 1 also has a couple of replicas. So you can see replicas for each of those partition 1s. So each partition is going to be part of a replica group, which has 3 different partitions. They're spread across AZs. One of them is going to be the primary that handles all the writes. Now, when this write comes in, it's still going to that primary partition. And that primary partition is going to write it locally. And then it's going to forward it on to both of its replica partitions as well. And as soon as one of those replicas comes back and says, hey, I got it, I've written it. Now we've got a majority. 2 of the 3 have written it. We can consider it durably committed. We're going to return it back to the client. So at this point, it's considered acknowledged back to the client, you that wrote it, right? And now if I do a get item, let's imagine I do a get item request right after that. It's going to go to that node, and it's going to figure out which partition it belongs to, and it's going to choose one of those nodes at random. And it's possible it could choose that sort of lagging replica, right? That replica that didn't return the fastest on that particular write, and maybe has a slightly outdated view of that data. Again, this replication lag is usually pretty small, so there's a small window. But imagine these writes and reads come pretty close to each other. So that may not reflect the latest write. So this is what's called eventual consistency, right? Eventually that replica is going to be up to date, but it might not reflect the latest acknowledged write. That's the problem. So let's think about eventual consistency and what's going on here. Eventual consistency, let's talk about the benefits, and then we talk about how it's not as bad as you think in Dynamo. So the benefits of eventual consistency, hey, it gives you lower latency writes, right? If I have to write it to 3 nodes and I have to wait for all 3 nodes to acknowledge it, now I'm waiting for the slowest node to handle that. And that's bad. By cutting out the slowest node, now I can have the 2 fastest nodes, and I still get durability and lower latency writes. So that's good. It also gives me higher availability, because if one of those nodes fails for whatever reason, now I have to wait for a 3rd node to spin up. If I'm writing to all 3 nodes for a write to acknowledge, I have to wait for a new partition to spin up, and I can't handle writes to that partition during that time. So by doing 2 out of 3, I get lower latency writes, I get higher availability. The cost is potentially stale data. So let's think about sort of what it means in terms of cost. So number 1, you can get strongly consistent reads on your main table if you want to, right? So I was talking before here, that request router is going to sort of randomly choose one of your nodes in a replica group to serve that read. And it could be to that lagging one that may not reflect the latest write. But if you go back to that get item and you add a parameter that says consistent read of true, now that request router says, oh, they want a consistent read. I'm going to go to the primary. I know the primary has the latest version of the data. The primary is the leader. It has to write to the leader. So I know I'm getting the latest version of the data there, and I can do that. It's going to cost me a little bit more in terms of what read capacity units I consume. It's going to potentially lower my availability a little bit there, but I know I have the latest version of my data. So that's one note. Number 1, you can get strongly consistent reads on your main table. Second most important note is that all writes are against the latest version of that item. You won't be writing against an outdated version of your item, right? You can only read it. So all writes are going to go through that primary partition. So it's not like you can have two writes come in at the same time. One of them's decrementing a balance here, one of them's decrementing a balance here, and they get resolved, and now we have a negative balance, right? So writes have to go through that primary for the partition. You can use something called condition expressions, which are saying, I want to assert something about the state of this item. And if that evaluates to false, don't write it at all. So you can say, only write only decrement this balance if the balance is higher than the amount I want to actually decrement. And you can make sure you don't get into those sort of situations. So condition expressions, super useful. Make sure you're using those. You don't have to, I don't want to say like you don't have to worry about consistency and stuff with writing, but at least like when you're writing, you know you're writing against the canonical version of that item. And if you're using condition expressions or versions or whatever you want to do, you can make sure that you don't have those sort of issues. So I'm not saying Dynamo, like if you really need strong consistency and there are certain use cases where I think it, maybe Dynamo won't be the right choice, but I think in most cases, people think they need strong consistency, and Dynamo is going to do more than enough for what they need for them there. Last thing, this one's a pretty quick one too. Dynamo doesn't have ACID transactions, another feature type thing, right? This is just false. Danilo's got this blog post. This is from 2018 at reInvent. They announced DynamoDB transactions. This was a huge feature when this came out. As you can see in the blog post, they are ACID transactions. So you get full ACID capability with Dynamo on those transactions. Just two quick notes on transactions that you need to think about. Like the big thing with transactions is contention, right? If you have multiple transactions or multiple write operations working on the same items at the same time, highly concurrent stuff, you're going to have contention there. You're going to have transaction issues. That's going to be true with a relational database or DynamoDB. So if you have highly contentious items, don't be trying to involve them in transactions. The second thing that I think is kind of interesting about Dynamo transactions versus relational transactions, there's probably a better term for this. Someone can help me here, but I call Dynamos like one-shot transactions, where you have to like gather all the changes you want to make. Hey, I want to write this item. I want to delete this item. I want to do a conditional check on this item, and send those all over in one single HTTP request. Dynamo is going to receive them, sort of handle that transaction, and then tell you did it succeed or fail. Whereas with a relational transaction, you say begin transaction, you send that to the database, it comes back. Now you say run this query operation, goes to the database, gets that, comes back to you. Now you say, okay, based on that, write this value in, does that, read another value, different things like that. And it's sort of back and forth, all these different network hops. That transaction can take who knows how long, right? You can have sub transactions in there, and you could just have a really long running transaction where Dynamo sort of limits the length the transaction can be. It's going to be one Dynamo operation. If there's another one contending with that at the same time, it's gonna reject one of them and get it out of there. It just limits the damage you can do from these transactions. So I think that's kind of interesting. It limits some of the flexibility of what you can do too, but I find that it doesn't really affect you too much in most cases. So
there was just a comment that came from Oracle. Transaction in DynamoDB is handled at code server. Relational transaction is handled by DB server. Does that make sense? Or
yes, I would say mostly, yeah. It's hard to say. I would almost think of it the other way, because I would think it depends on what you're thinking. Like I'm going off. I'm not making sense here, but I would say Dynamo sort of happens at the DB server because it's like you're sending all this stuff and it's handling all that stuff and sending it back to you, whereas the relational one could be happening at your code server. I guess the way you're sort of thinking about it is just like you've done all the work to think about it at the code layer and then just throw that batch over, whereas the relational one is not. So yeah, but yeah, it's definitely like a flip in how transactions work. And I think like a lot of other Dynamo features, it prevents you from things that can hurt you, from bad patterns, from performance issues at the expense of less flexibility in some ways.
Yeah, and I suppose related to that, Siddharth said, when using transactions, is it possible to use the result of a get item in a subsequent update item within the same transaction?
No, I believe. I need to double check that. I think no. There's a little bit on transactions where I wish you could return the results of items. Usually you need to make a follow-up request right after that if you need to get that. If I recall, it's been a hot minute. I don't know if Kurt can help me on that one if he knows that off the top of his head. But I think the answer is no, which is a little frustrating. Yeah. And I think that was it. So that was a quick one. Dynamo doesn't have ACID transactions. It absolutely does have ACID transactions. Again, like other transactions, make sure you're watching your contention, but you can use these for a lot of interesting use cases. So, summary. DynamoDB reality, right? It's more than a key value store. You can handle your unbalanced load. Your data model can change. You can have strong consistency, and you get ACID transactions. Don't let any of those be reasons. There are caveats in different areas, or maybe there's other features where you don't want to use DynamoDB. But I just want to make sure, hey, you know what Dynamo can do, what it's really great at, and why people are loving it. I think that's all. Yeah. I'm happy to answer questions, but I know we're already 5 minutes over, so whatever works for people.
Well, I think that because normally on our Serverless Land YouTube channel, we've got as much time in the world, but the AWS Twitch channel, there's normally a show coming after us, but I think they obviously looked at the schedule and they went, DynamoDB with Alex de Brie. There's absolutely no way we're going to risk scheduling something after that, so it's been a pleasure to have you extra. We will say goodbye, but just for next week, there are some questions coming in as well, so keep them coming if you do want. But yeah, next week on Serverless Office Hours, we've got Lambda cost optimization. So I'll be chatting to Chris Williams and Thomas Moore. And reducing your costs with Lambda, they'll have a whole bunch of different tips and tricks to be able to do that. Then also, I mentioned earlier the serverless snippets collection. So when I was tripping over my words, I couldn't think, but it was CloudWatch Logs Insights, and also some tools and some integrations you can use in various languages with various services. So Dave Boyne has put these together. So yeah, I use CloudWatch Logs Insights regularly, and I have a notepad of these. Now it's all open source. It's all open source on GitHub as well, so we'd love you to contribute your own things. There's also the workflows collection, which is recent. So this is all step functions workflows that you can use, and a concurrency controller, how to automate Zendesk, support ticket moderator. I'm just seeing over there, and Ben has created some of these fundamental ones and some patterns and some whole applications that are also from the community. So that is super cool. And then the regular serverless patterns collection, now over 300 patterns. I just before going on vacation/holiday, I contributed a few myself, and we've got some more coming. So yeah, all sort of super useful. And in general, serverlessland.com, all your information about the serverless, from blogs, videos, learning paths, events, and all the patterns kind of stuff. But wow, this has been an absolutely awesome. I've learned a huge amount of DynamoDB. I am certainly no expert. I see myself as a beginner with all these kind of things. So, Alex, it has been a pleasure having the DynamoDB guru on it. And I think we obviously, it's clear with the number of viewers and the number of questions, we're going to obviously have you on again if you don't mind. So,
absolutely.
Thank you very much.
Thanks for having me, Julian. This is great. I'll be here next week watching the cost optimization stuff. So, thanks for having me.
Oh, cool, excellent. Well, thanks so much. And yeah, Kirk is also an internal person from AWS, NoSQL Know-How. Thanks so much for joining us as well and answering some of those cool questions. And yeah, please contact me on Twitter or Alex themselves if you've got any other kind of things. And yeah, if you have any suggestions or things to do with Serverless Office Hours you'd like us to cover, please get in touch. Always happy to see what we can provide and what you'd like to listen to and see. But Alex, so thank you again so much, and see you. Well, Alex, you will be watching, but see anyone, same time, same place next week. And yeah, thanks for spending time with Serverless Office Hours, and happy building over the next week. Goodbye, and thanks.